Alright, hello Trig. So today we are finishing up, hopefully, these nonlinear inequalities. So a couple things we didn't get a chance to talk about in class yesterday because we ran out of time because the end of class was rather hectic yesterday. So a couple more things with this before I set you loose on the homework. So if you got something like this, if all of our things are negative and if we got some slightly bigger numbers here, the first thing we're going to look for is there anything that we can take out of all of our terms first? So we're going to do that first. So we're going to just go ahead and take out a negative. And 8 and 30 and 18, if we're looking for something that goes into all of those, we're going to go ahead and also factor out a 2. And all of these have an x. So we're going to factor that out before we do anything else with that. And that's going to make it look a little bit nicer. Not like super duper nice, but at least it's going to be nicer than this. So if we take a negative 2x out of everything, negative 8 divided by negative 2 is a positive 4. If we take an x out of our x cubed, we got an x squared. If we take a negative out of our negative 30, we've got a positive. 30 divided by 2 is 15. And then x squared divided by x is another x. And then again, your two negatives are going to give you a positive. 18 divided by 2 is 9. And that x just went here, so now we just got a 9. Okay, so that makes this a little bit nicer to deal with. Now, the other thing we can do is if we want to get rid of that negative 2, we can just, divide by that and it's gone. Now, however, watch out for when you do, if we have an inequality and we're dividing by a negative, we need to remember to, hopefully you just said swap the sign of this page. So we're going to swap that sign. This is still a 0. We just need to remember that since we divided by a negative, that sign swaps. So now we've got this, which isn't particularly delightful, but at least it's a little bit nicer than this was. So now, if you have some factors that are jumping out at you, that's fine. So if you happen to realize right away that we have some nice factors, because really your only factors of 9 are either 1 and 9 or 3 and 3. And if you happen to realize that 4 times 3 would get you a 12, and 1 times 3 would get you another 3, and 12 and 3 gives you 15. If you happen to see those right away, you can save yourselves a little bit of quadratic formulating time. If you didn't happen to see that and you went through to do the quadratic formula on this, that'll work. It'll just take you a little bit longer. Okay, so now if we're looking for where that equals 0, we've either got x equals 0 here, or if we solve for x plus 3 is equal to 0, we're subtracting 3. We're dividing by 4. So we've got negative 3/4. Or over here, we've got x equals negative 3. So those are our 3 x-intercepts. So those are our 3 things that are going on our number line. So we've got a negative 3, we've got a negative 3/4, and we've got a 0. Okay, so if we're looking at our x-intercepts there, so those are places where our graph is changing from either a positive to a negative or a negative to a positive. Now, some of the ones we were doing in the examples before were parabolas, and we have a pretty good idea off the top of our head what a parabola looks like. If we're not sure what this is going to look like off the top of our heads, because, okay, we've got a negative here, we've got an x cubed. Now, if you happen to remember that if we have a negative in front of our x cubed, it's going to look something like this, then you can save yourself a little bit of time plugging things in. If not, that's fine. Now, just watch out for when we're plugging things in. If you're plugging them back into this, we're looking for where we're less than 0. If you're plugging them into this, then you're looking for where they're greater than 0. So either one's okay, you just want to keep track of which one you're doing. So if you did not remember that these look like this, and you went and plugged in, say, 1. If we're plugging in 1, if we're plugging it in back here, we're looking for where we're less than 0. If we're plugging it in here, we're looking for where we're greater than 0. I'm just going to go with the one up top. So if we're plugging in 1, we've got a negative 8 times 1. 1 cubed is 1, so this is negative 8, which is why I picked 1. 1 is nice. And then minus 30, 1 times 1 squared is 1. times 30 is negative 30, and then minus this 18. So that's why 1's kind of nice. And you don't actually have to go through and do all this, because we know that if we have a negative, subtract some more, this is going to be a negative, which is what we're interested in. We're not really interested in what's that number. We're just looking for, is it positive or is it negative? So we know now that it's negative over here, which is confirmed by what we know that graph looks like. So if we got 3 x-intercepts along this graph, we're thinking this is going to be positive, negative, and it sure looks like that's what's going on over here. So we got positive, negative, positive, negative. So again, as soon as you found 1, the others are just going to alternate around that as long as we don't have any of those double root things going on. So as soon as we found 1, we've just got alternating positives and negatives from there. Now, again, if you want to double check that either by graphing or by plugging in some more numbers, that's fine. If you happen to remember that that's going to be that pattern, that's also fine. So since we plug things back into the top one, we're looking for where we're less than 0. So the sections of our graph where we're less than 0 are going to be where we're negative, which is here and here. So here we're between negative 3 and negative 3/4, or if you call that negative 0.75, that's fine too. And over here, we're from 0 over to infinity. And since this was a less than rather than a less than or equal to, that's why we've got those parentheses rather than brackets. If it had an equal sign under it, then they'd be brackets instead, because we want to include those points. Okay, now, over to the fraction ones. So these are the ones where we want to take everything and scoot it over to one side of our inequality first. I'm just going to recenter this. Hang on a second. There we go. So we want to scoot everything over to one side of our inequality. So we're going to scoot this 3 over here. Okay, and now in order to add or subtract things that have fractions, we need some common denominators. So we're going to take everything over here times this x plus 4, get ourselves a common denominator. So we're taking this times x plus 4 over x plus 4. So now we got x minus 3 up top, minus 3 times this x plus 4 over this x plus 4. You can see me saying x plus 4. Okay, so we're distributing this. So I got x minus 3 minus a 3x minus this 12 over that x plus 4. We're just going to make that look a little bit simpler, combine some like terms. So we got a 1x minus 3x is negative 2x. Negative 3 minus another 12 gets you negative 15. And we got x plus 4. Okay, and now the two things we're looking for with our fractions is we're looking for our x-intercepts, but we're also looking for our asymptotes. So the reason we didn't have an asymptotes back here is because this was a nice polynomial function. So we don't have anything that would give us an asymptote, because those are coming from where the bottom of our fractions equals 0. So this x plus 4 here is giving us an asymptote at x equals negative 4. So that's our only asymptote this time. And our x-intercept is coming from where does negative 2x minus 15 equal 0. We're going to add 15. These are gone. And we're dividing by negative 2. Which gives you a negative 7.5, or if you let that as negative 15 halves, that's fine. Okay, so those are our 2 points on our number line. So we've got a negative 7.5, and we've got a negative 4. Okay, and again, we're just looking for one section that's positive or negative, because then after that, it's going to alternate. So a nice thing to plug in is going to be either 0, 1, something like that. So if we're plugging that in, I'm going to go with plugging it in here. Technically, you can plug it in back here. The reason you might not want to is that we're looking for is that greater than or equal to 3 rather than is that greater than or equal to 0. So you could also do that. I'm just going to go with 1 down here. So I'm going to plug in 0. 0 minus 15 is negative 15. 0 plus 4 is 4. That's negative. So now we know that over here at 0, our graph is negative. which means that since we don't have any of those double root things going on, we've got negative, positive, negative. And then what we were looking for is we were looking for where our graph was greater than 0, also known as where our graph is positive. So we're looking for this section of our graph. So between negative 7.5 and negative 4. Or again, if you wrote that as x is less than negative 4 and greater than negative 7.5, that would also be okay. Just remember that if you're double checking your answers in the back, they'll have this rather than this, but it's the same thing. Either one's okay. Okay, let's do one more of those. Okay, so same sort of thing. We're going to take that 6 and we're going to subtract it over to the other side of our inequality first. So we got 3x minus 2 over x plus 3 minus 6 is less than 0. In order to add or subtract things that have fractions, we need some common denominators. So we're going to take this times an x plus 3 over an x plus 3. So we got 3x minus 2 up top. Minus, I'm just going to go ahead and distribute this here. We can combine that step now. Minus the 6x, and then minus 6 times 3 gives you 18 over that x plus 3. And now we're combining some like terms, so 3x minus 6x gives you negative 3x. Negative 2 minus 18 gets you negative 20 over x plus 3. And then once we've got that, so once everything's in one fraction on one side of our equal sign, or not equal sign, inequality, and we got 0 on the other, then we're looking for our asymptotes and we're looking for our x-intercepts. So this x plus 3 on the bottom means we've got an asymptote at x equals negative 3. And then up top, we want to know where is negative 3x minus 20 equal to 0. We're going to add 20. We're going to divide by that negative 3. And if you left that as negative 20 thirds, that's fine. If you turn that into a negative 6.6 repeating, that would also be okay. Either or. So then those are the two things that are going on our number line. So you got either a negative 6.6 or a negative 20 over 3, depending on how you wrote that. And then we got a negative 3. And again, I'm going to plug in 0 just because 0 is nice. So if we plug in 0 here, we got 0 minus 20 is negative 20. 0 plus 3 is 3. That's a negative. So over here at 0, our graph is negative. And since we don't have any double roots, we're alternating positive, negative, and then negative over here. So negative, positive, negative. And again, if you want to double check that by graphing this, that is 100% okay. Feel free to pull up Desmos, graph it, make sure that checks out with negative, positive, negative. Okay, and then we're looking for the sections of our graph where we're less than 0, which is where our graph is negative. So this section over here and this section over here. So this section over here is where x is less than negative 6.6 repeating. Or again, if you want to write that in integral notation, that's negative infinity up to negative 6.6 repeating. And then this other section over here from negative 3 to infinity. Or same thing, if you call that x is greater than negative 3, that would also be okay. So either both of these or both of these. So either one's fine. Not going to be picky about whether you put it in integral notation or whether you left it like this. It's not the main point right now. So either of those is okay. Right, and that is pretty much it for nonlinear inequalities. So go ahead and check out the homework that's either in the description or I believe it already posted yesterday in Google Classroom. So once you're done with that, you can either screenshot that, take a picture of that, go ahead and email me that, just so you don't have to wait until we're back in school to hand the piece of paper back to me. So go ahead and give the homework a try, and I will see you in the next video.